Okay, before we get started with demo, I want you guys to all pat yourselves on the back for getting through all this. Today will be our last demo and last lecture for actually building a backend. Starting next week rather, we'll be learning about how to deploy our backend and how we'll make it accessible for other users to use. So yeah, let's take a moment to just appreciate how far we've come so far. Now we can communicate from our laptops, from our phones, to these servers that we built and store information as desired, right? So, little congratulations. Okay, let's get started with the last lecture for building our backend. Last demo. The first thing that's really annoying, and I apologize, this is really annoying, is that our textbook is in Gitbook and it's really jank. And so if I actually open Abstractions here, like this week's page, you can see that there's only 4 things there, but if I refresh it, like the pre-class to-do shows up. So just like, this is because some of the information that's on Gitbook is cached onto your computer. So if you could go ahead right now and go to Gitbook, go to refresh it first, and then go to the pre-class to-dos and download the starter code. It should look like what I'm about to use next. So give everyone a minute to do that. Okay. Okay, so hopefully we're all good. So I'm going to get started for a demo. So as usual, let's cd to our folder, right? And we have to create a virtual environment. As usual, we want to be creating a virtual environment outside of the source folder because the source folder just contains our code. Let's do that. Can everyone see this, by the way? Is it too small? Is it too... No, we're good? Bigger? Okay. That's going to mess up with my ZSH. Okay. All right, so now we have a virtual environment. Let's activate it. And let's cd into our source folder. And let's install our requirements.txt. So if you've, you should install the virtual environments every time. But for whatever reason, if you haven't been doing this, this week's requirement.txt is going to be slightly different than the past weeks because we're using our ORM called SQLAlchemy. So make sure you do this. So let's go to our code. Be out of this and go to our code. And that is very small, so let me make that bigger. So this is what the starter code should look like. If this is not what you see, please go re-download from our textbook. Oh, this isn't actually the DB file for this this demo. I'm just having it here to show off what we did last time. Actually, let me just like hide this for now. Okay. All right, cool. Bigger? No, I can't see anything. Is this good with everyone? Show of hands if people can't see it. Can't see it? Can't. Okay. Let me get one bigger. Is good? Okay. All right, so let's go over just quickly some setup stuff. As a lot of us have been doing for our past PAs and demos, we have to import request. Oops, request, sorry, singular request. And yeah, so let's just quickly go over what all of this is. Close the what? This? Oh, this? Okay. Okay. So again, like Kate mentioned in lecture, an ORM is basically a translation between SQL code to Python code, right? It abstracts the SQL out of it and makes it into Python code, which a lot of us are, one, more familiar with, and two, is very nice to type in VS Code because we have syntax highlighting, right? So yeah, that's what an ORM is. So let's go over what all of these are doing. So db_file name is just the name of our file. We're creating our app, our Flask app as usual. These things, you can look up what each of these do by just typing in, go to your browser and type in SQLAlchemy configuration. And you can go here and look at them in detail if you really want to. But I'll quickly go over what each of these are doing. So the database URI is telling the SQLAlchemy library, hey, this is the type of SQL library I want to be using, right? SQLite 3, and what the file name of that SQLite file should be. So in our case, it would be todo.db because we're continuing on with our demo from previous lectures. This thing, just don't worry about it, just have it. If you really wanted to look it up, but you can, but yeah. And this thing is really cool, SQLAlchemy echo, because what it does is it tells us when we run our app what SQL code is actually running. So again, we're going to be abstracting away the SQL code and typing in Python code. But if you really are curious about what SQL code is running under the hood, then you can put this to true. But it can clutter up your terminal quite a lot. So if you're just not curious anymore, you can just set this to false, and it will not print as much information out. So that's what these things do. These are just some syntax stuff for initializing the app, and you won't have to worry about it too much. But create all creates all our tables, which we'll define in a second. So that's what that does. Okay, and for those of you who may not have understood what these do from previous lectures or from previous demo, it takes in two parameters. It takes in data and code, and kind of just dumps it into this function. However, you can see that code actually has an equal sign and a value after it. This is a default value. So if you don't specify the code, it kind of just uses 200 as a default value for you. So I have an example open right here. Okay, ignore all this stuff. I was testing. We have a function that says print code, and the first parameter is optional, and we have a value of 200, and just prints the code that we pass in. So if you do print, and I don't pass in this optional parameter, it'll just, okay, that. Well, okay, you can see up here. Oh, wait, it's because I typed. Okay, that's my bad. If I call the function and I don't pass in anything, that optional parameter will just take in this default value and print that code. But obviously, if I do specify it, then it'll override it and use that value. So that's what this success response and failure response thing is doing. It takes in a data and it takes in a message. Because a lot of our JSON.dumps line is always going to look like this. But our code, we can specify if we'd like to. But in the case that it's the usual 200 or 404, in case something's not found, then it'll just use this default value. Does that make sense? Cool. I'm aware not all of you have taken 1110, so I'm just quickly going over that. Now, let's move on to our db.py. And start some stuff here. Cool. So how is SQLAlchemy going to abstract SQL code to Python code? In SQLAlchemy, instead of like in SQL where you have tables and you have entries in a table, you have classes and objects, like we're all familiar with. So for instance, if you wanted to make a task table, we would make a task class and make objects of that class, right? So this is like a translation between SQL and Python code. So the first thing we'll make is the class table. Let's do class and call it tasks. Again, this is Python code that we're typing, so it should be in Python syntax. So let's say we have like tasks to do, right? You wouldn't do task to do because that's in snake case. we would do it in as such for Python class names. So let's call it tasks. And we'll specify that this is a db.model. So what this means is that this task class we're making is a model. It's a blueprint of the objects we're going to be making. This is just telling SQLAlchemy, hey, this task thing is a model. It's a blueprint for all of the entries that we're going to be having. Next, we can define our table name by doing __ table name equals, and then the name of the table. So this would be in SQL syntax, which is in all lowercase. And now we can go ahead and start defining what all of our columns are. So we have, right, let's actually compare this with our previous db.py. So this is from demo 3, I believe. We have a task table, and we have an ID, a description, and a done field, right? So this should look familiar to you guys. So let's go ahead and create that ID, right? And oops, it just auto-filled for me, description and a done field. So what goes in one of each of these? Well, as you probably, you're seeing here, you can specify a column in SQLAlchemy by doing db.column. You can specify the type of the data that's going to be going into these, right? So that's integer. So that's db.integer. We can specify that it's a primary key by doing, primary key equals true, as it says right here. Looks like that. And finally, okay, it doesn't have auto increment, but we should have that. So we have auto increment equals true as well. So let me do that. So again, the great thing about ORMs is that since you have syntax highlighting, you can see here that it has syntax errors right here. Or if I call this like, let's say I don't know, colon. It should, okay, maybe it doesn't. Maybe my SQLAlchemy is broken. But essentially, it's much more obvious if you make a mistake here, as opposed to if you make a mistake in SQL, raw SQL. So if I have a comma here, right, it's not going to tell me anything. And maybe I'll spend hours debugging this comma. That's a great thing about ORMs. So let's continue on and define these columns. So again, a description is a text. A fantastic thing about SQLAlchemy is that we will no longer have to call these things text, but rather strings, as we're all familiar with. So we'll call this db.string. And this cannot be null, as per previous demo. So we'll do nullable equals false. And then let's do the same thing with done. So db.column, db. Okay, and another great thing about ORMs, oh my God, I'm selling this so much, is that we actually have Boolean support. And so basically, like Kate said, an ORM, once you specify what kind of SQL library you're using, say SQLite 3, it knows that SQLite 3 stores Booleans as zeros and ones under the hood. And when you specify that it's a Boolean, it'll handle everything of converting zeros to false and ones to true and all that for you, which is fantastic. So let's do that. Now, we want to be able to initialize an instance of this class. So to do that, this may be familiar to you who have taken Python 11.10, but we have an init function where we have self. And we'll be using this crazy thing called a kwargs, which stands for keyword arguments. Now, another quick demo on what kwargs is. So kwargs, you can basically pass in whatever you want. And you can already see I was practicing earlier here, SMH, ZSH. But let's say this demo function takes in a kwargs argument, and it just prints it. If you do a demo and then pass in Shungo, or no, oh my God, what is going on? Demo name equals Shungo, and age equals 20. I'm 20 now. Oh my God, I'm old. You'll see that whatever is printed is a dictionary of the key being the argument name and the value being the value that's passed into that argument name. So that's amazing, because now if we go here, we can do self.description equals kwargs.get, again, because kwargs is a dictionary, right? It's a dictionary. So this should look familiar to you guys who did PA1. Kwargs.get, and then our description. And then we can even specify a default value when we do the .get function. So we can specify that if we don't specify a description, just assume it's an empty string. And then self.done, same thing here. Kwargs.get done, and our default value can be false. So the great thing about this is that instead of having to do, description and done every single time, we can just have like a kwargs kind of just take in all the arguments that are given to me and convert it into what's necessary. That'll be our init function. Object. All right, so entry in our table. And then let's make so the issue with this code right now is that it's a Python object. And we have to somehow convert this into a JSON format. And as we all learned, JSON.dumps can take in a list, it can take in a dictionary, right? It can take in a lot of things, but it can't take in a Python dictionary. So we have to make, a Python object. So we have to make a function that will convert our objects to dictionaries. And the process of doing that is called serialization. So let's make a serialize function. And let's just return the dictionary. Oops. And we'll have ID is self.id. We'll have description is self.description. Oh my. And then we'll have done is self.done. Cool. Pretty good so far. Does make sense. Okay. Now, from demo 3, we had another table. We had another table called subtasks. So let's make that subtask class. Wait, realize object. We can call it object. So class subtasks, and it's another model. And as you can see here, a lot of it is going to be the same except for task ID. So I'm going to use the best tool in programming called copy and pasting, and just do that. Are we good with this, or am I going to be scolded? Are we good? Cool. Okay. So we have an ID, we have a description, and we have a done. That's identical to our task. Next, let's create the task ID field that we very much needed from back here. And this is another column, right? It's our foreign key column. The task ID is always going to be an integer, so that's the same here. No, it is not a primary key. So the way we specify that it's a foreign key in SQLAlchemy is by doing db.foreign foreign key. Did I spell that right? Okay, I spelled that right. Foreign key, and then in quotes. And this is going to be very similar to what we did with SQL right here. We have the name of the table, and for God knows why, a dot and then the field, not parentheses like in SQL. And then we have to set that nullable to also be false, because we cannot have a subtask just be laying there. Let's do the same things we did up here. So init and serialize. So we have an init function, and we pass in self, and we pass in the keyword arguments, and do the same thing from back here. Also, if you're wondering, having triple quotes here and just having the one-liner comment, basically equivalent. As long as you're commenting your code and we understand what you're doing, feel free to use whichever one you're more comfortable with. Okay, init function. we have our description, we have our done, and we have self.task ID is equal to kwargs.get task ID. Now, the reason why we don't specify a default value for here is because, well, we don't have a default value, right? There's no default task to associate a subtask to. So if this constraint is failed, right? If this task ID thing isn't actually passed in, then you can just assume that the subtask creation was failed. So it's fine if it crashes when you don't pass in a task ID because that's the front end's fault. Nice. We love to blame front end even though we break everything. Finally, I'm going to close this because that's basically all the information we needed from the demo 3. We'll have to have a serialize function as well, so let's do that. Self serialize a subject, and let's do return. ID is self.id. We have description is self.description. Done is self.done, and we have task ID equals self.task ID. Beautiful. Okay. Cool. So now that we have these two models, let's go back to app.py and start implementing the functions for these two models. Go back to app.py. Does anyone need to copy db.py? Should I leave it up? Anyone? Okay, I'll leave it up. Hopefully you can kind of assume what goes in here. Move this up here. All right, so we have our success response methods and failure response methods. So in case we have a successful response, we can just call this function and pass in the data. And we have a failure response, we can just pass in the message, and it'll return the expected error. So let's define this one, get tasks. Here, we can do return success response. And we have to make a dictionary, just like last time. We have our tasks, and we have to get the tasks that are in our tasks table. So the way we do that is by doing, actually, one thing we can do is do a task and do for task in. Oh, okay, sorry. One thing I forgot to do. Since we have classes here, we have to actually be able to call these functions. And to be able to call these functions, you have to import them from up here. So let's do from db import tasks and from db import subtasks. All right, that's a few classes we made. We're good? Let's go in here. And now we have a class called tasks, and we can use SQLAlchemy methods on it. So we can, the way we select star from the task table in SQLAlchemy is by doing .query .all. So this gets all the tasks in our task table, and this is a for loop, right? So we're looping through every single task in our task table, and we're appending it to the tasks list that we have up here. So task dot serialize. And then we can pass in this tasks list. So now we have a list of tasks, right? We initialize an empty list, we query through each task in our list, and then we append it to our list. We append the serialized version to our list, right? Because we can't have objects being returned as JSON formats. And then we return it as a successful response. All right. Does this make sense so far? Amazing. So let's go ahead and actually just run this. Let's get rid of all that. Python 3 app.py. And you can see all the SQL queries being done to create these tables. Kind of cool. We don't have to worry about it too much. So let's go to Postman and then zoom in on this as well. Oops, that's too big. Okay, and go to our workspace. Let's call this demo 4. Oops, demo 4. And create a new request. And let's call it get all tasks. Oh. To send this request, it should successfully give us the list of tasks. Okay, so that's going to be it for demo. We're going to cover how to insert, how to update, delete, all that stuff next time. But so far, we've made 2 models, right? And we can query from them. So is everyone good so far? Do we have any questions before we move on to Kahoot? Yeah. Okay, why don't you go help? Okay. Let's wait for a bit and then start the Kahoot. Cool. All right, let's get started. So the first thing we have to do, right, this is our code from last time, is fix a few stylistic changes that I made last time. So with all of your codes up, please change your class names to be singular. By Python standard, all your class names should be singular. So we'll change that and we'll go to app.py and also update those here. Let's do that. And then I also mentioned that you can comment with either the hashtag or with the triple quotes. That was actually incorrect on my end. So all comments for functions and classes should be in triple quotes. This is something called docstrings, and it appears right after function definitions and class definitions. And with some libraries, you can actually do really cool things. Like, for example, if you have docstrings, there's this library called Swagger API that kind of shows whatever you have in the docstrings for you. And it's just like a standard to have them immediately after the class names and the function names. So let's go ahead and fix that. So this is the task model, and it has a one-to-many relationship with the subtask model. And then this initializes our tasks object. Initializes the tasks object, and this serializes the task object. And this is our subtask model. And same deal down here. So initializes our subtask model. Task object. Task object. And serializes task object. Here. Okay, cool. So that is all we have to fix in db.py. So hopefully you got that out of the way. And now with that out of the way, let's just quickly go over what we covered last time. So we learned to create, using SQLAlchemy, we learned to create 2 classes, right? We created the task model and the subtask model. They have a one-to-many relationship, so each task can have multiple subtasks associated to it. And using that model, we created one endpoint for getting all tasks. We're good so far. Okay, awesome. Okay, so last time, one thing we did. Oh, you good? Okay, last time one thing we did is we created a list of tasks and returned them in the success response as such. Right? We initialize it to be an empty list, and we loop through everything, loop through every task that we found in our task table, appended it to the list, serialized it so that it's in a returnable format, and then dumped it in a success response. However, one cool thing we can do with Python here is to do this. So I'll quickly go over what exactly this does. But for those of you who haven't taken 1110 and aren't particularly familiar with Python, this loops through every element in the last, in like the third parameter. And it's kind of like using for t in this last thing, task.query.all, and runs this operation on each of those objects. So I have a quick example again, as per usual. So I define a function called add1, and it just returns whatever's passed in plus 1. So let's create a list called 1, 2 that has 3 elements, 1, 2, 3, and then we just loop through demo plus right, we can do the traditional loop method. Oh wait, hold on. For n in range length demo plus 1 plus 1 at an element is equal to add 1 and then demo plus 1 and then n. So this is probably very familiar to you guys, right? It just incremented every element in the list. But another way we can do this is by doing add 1 n for n in demo plus 1. So again, this is what we loop through, and for every element in whatever we're looping through, we run this operation on it. So this is just like a little neat trick that we're going to be using for the rest of the demo. So this is why I wanted to make a quick demonstration of how this works. So hopefully that's a little understandable. With that out of the way, let's now work on creating a task. So we now know a way to get all tasks. We do task.query.all and serialize each task that we find in there. So to create a task, as usual, we'll JSON.loads the request body, and we'll create a new task, right? To create a new object in Python, we have the class name, and then we pass in the parameters. And the parameters here is the description and the done, right? This is what we covered last time. So we have description equals body.get description, and we have done equals body.get done. So now we just created a new task object, and we have to append this, or we have to add this to our database. So the way we do that is by running db.session.add, and then the newly created task. And then we have to db.session.commit. So a lot of this will look familiar to what we did with SQLite 3, in that you're adding it to that table and then committing. A lot of people are questioning why we have to run this commit function. And it's like, okay, like why can't you just integrate the commit function into the add function, right? Like why can't add run both the add operation and the commit operation for us? Well, that's because the commit operation is very slow to do. So you want to be running it as little as possible. So just keep that in mind. If you make a few changes, you want to make those changes and then commit like at the end, just once, instead of like committing after every single change. So that's why commit isn't part of the add function. But that's a little thing to just keep in mind. And now let's return a successful response. Success response, where our newly created task is what we return. So new task.serialize and 201 to indicate successful creation. Cool. So let's go ahead and test this on Postman. We have demo 4 for getting all tasks. And we can duplicate this, call it create new task. And we'll make this a post request. Let me make this bigger. Okay. Turn this into a raw JSON entry. And we have description equals good X or something. done equals false because I'm bad. Oh, I didn't start the server. That is problematic. Let's open a new terminal and activate a virtual environment. Actually, it's already activated. Python 3 app.py. Oh. It wasn't activated. Let's do that. Okay. So again, we're starting our app as we've done multiple demos and assignments in a row. And then let's create a new task. Right, so that did the exact same thing as we've seen from demo 2 and demo 3. Amazing, awesome. If anyone needs help, feel free to raise your hand in the middle of demo. We have a few core staff here to help you out. Awesome, okay. So now that we've done that, we can move on to our next endpoint, being getting a task by its task ID. Oh. So we can do task equals. All right, so remember the format up here. It was task.query.all. So .query starts a query, and this is like the function afterwards that we have to decide on what we use. So task.query. And then the one we'll be using here is filter by. So this is basically like a condition that you can pass into the parentheses here. And it returns you the task objects that only the task objects that match that condition. So the condition is that the ID is equal to the task ID that's been passed in. And then this actually gives us a list of tasks, even though we only have one, because filter by doesn't know that it's only going to be one. So we have to indicate that we have to get only the first one, which we can do by doing .first. So this gives us the task with the ID task ID. As usual, if the task is none, then we haven't found the task, so we can return a failure response. Task not found, right? And our default failure response code is 404. We covered this last time as well. And so we don't actually have to pass in a code. And finally, if the task is not none, meaning the task was found, then we can return successful response, tasks.serialize. Oops, I spelled that wrong. So again, serialize is to convert a Python object or something from one type of data into like another that's more usable for whatever you're trying to use it for. So for example, in this scenario, we're converting it from a Python object to a JSON like returnable format. Okay. So let's make a new Postman request and call it get task by ID. And our endpoint, as usual, is tasks, and then the task ID that we're passing in. So when we created that earlier task, we have the ID of 1. So let's hit that endpoint, and we can successfully get the tasks that are created. All right, everything so far should look pretty familiar. Is everyone good so far? Yeah. Do you have a general question or? Okay. Can one of you go? Yeah. Okay. Awesome. So yeah, we've covered how to get all tasks. We've covered how to create one. We covered how to get one by its ID. Now the remaining two for tasks specifically is to update one or to delete one. So let's go with updating first. Right, so as usual, when we want to update a task, we have to retrieve the description. Request.data. Task equals task.query.filter by ID equals task ID, right? We're retrieving the task that we are specifying with this task ID. If task is none, then we haven't found the task, so we can return a failure response. And then task.description. So here's a cool thing about SQLAlchemy is that task is currently a Python dictionary, but we can actually change our Python dictionary and just call db.session.commit as we did up here, and it'll actually commit those changes, even though the only changes we're making is within the Python dictionary. So what I mean by that is task, again, is currently a dictionary. Or no, it's currently a Python object. It's a task object. So it has an ID field, it has a description field, and it has a done field. And we can access each of these fields by just doing dot and then the field name. And we can set it to be whatever is passed in from the client. So what this does is it sets it to the description that's passed into us. But again, .get is a function in Python that we can use where we look up a key, and if the key doesn't exist, it uses this default value as the output of this whole thing. So it basically takes in the user input, but if the user input isn't specified, then we just default it to whatever it was previously. This allows us to only edit description or only edit done or edit both if we'd like to. So yeah. And task.done is the same thing, right? Body.getDone and task.done. So the previous value of task.done unless specified by the user. Now, a thing to note here, like I mentioned earlier, is to run db.session.commit as little as possible because it's a very slow operation. So I wouldn't actually run it here, even though I have made a change to our table. Hopefully this makes sense. So you run multiple changes and then you finally commit them once you're done with those changes. Now, finally, we've successfully updated our task object, so we can return a successful response, task.serialize. So let's test that too. Let's duplicate this, and let's update a task by ID. This is a post request, because we're sending data to the server, and change this to JSON. Description. So what do we want to change our first one? I don't know. Maybe the description can be the same as it is, but the done is true because somehow I suddenly just did get good at Smash. Cool. Okay. This is actually a lie, so I'm just going to change this back to false. But hopefully that makes sense. Are we good? Okay, let's move on to deleting a task. We want to, as usual, retrieve a task, right? Task.query.filter by the condition, which is ID is equal to the task ID that's passed into us, dot first. If task is none, if task is none, then we return a failure response where task is not found, right? This should feel very familiar by now. Now, how do we delete something from our table? Well, we ran db.session.add earlier. So the flip side is db.session.delete. And then the object we're deleting being the task that we just retrieved. Let's commit that change, right? So every time we make a change to the table, we want to be committing them. And finally, oh my God, stop doing that. Finally, we want to return this task like we have been when we delete something from our table. This is more like a sanity check, right? To check if the thing that we deleted was indeed what we wanted to delete. So we can return a successful response, task.serialize. Okay, so let's run another Postman test. Delete task by ID. This is now a delete request, and we want to delete the first task. Let's check that we have all our tasks now, right? We still have our task to get at Smash, and then we can delete it by specifying the ID of that task, which was 1. Right, and now it returned us the task that we deleted, and if we go to get all tasks it should give us none of the tasks because we successfully deleted it. Okay, so that was our demonstration on tasks. Now, earlier on during Monday's lecture, we implemented subtasks as a different model. So that's a one-to-many relationship. And so let's cover how we can make endpoints for the subtasks. I'm going to add this task back. Oops. Just for the sake of having a task to add subtasks to. All right, let's move on. Create a subtask. How do we create a subtask given a task ID? Well, first we have to retrieve the task to know which task we're even referring to in the first place. So this is, again, very similar, task.query.filter by, and ID equals task ID.first. If task is none, then return failure response. Task not found. Otherwise, we want to be adding a subtask to this task. So we can do body equals json.loads, request.data. And like I mentioned earlier, the triple quotes string that we put after a function definition is called a doc string. This tells us the description of the function or the description of the class. But when we want to write inline comments, then we use a hashtag. So this hashtag is for like little notes that you leave in your comments or in your code, right? So if someone else is going through your code, they'll be able to understand your code better rather than having like a bunch of lines of code that doesn't really make sense to them. So next I'm going to create new subtask object and commit it to DB. So let's do that. Let's create a new subtask object. All right. We mentioned earlier on how to create a task object. We do task equals, right? A new task equals task and pass in the parameters as desired. So we can do the same thing where we do new subtask equals subtask and then pass in the desired parameters. So the description is body.get description. Our done is body.get done. And our task ID, right? Well, this isn't body.get task ID because we're not passing it as part of the request body, but rather as part of the URL, right? So this is from PA1, from endpoints. We can just pass in the task ID as passed in from here, from the URL. Now, what do we do with the newly created subtask? Well, we append it to our session, new subtask, and let's commit that change. And finally, we'll return a successful response saying that our new subtask was successfully created. So let's go to db.py and see what we actually did just now. When we initialize a subtask, we set the description to be the description that we pass in, the done to be the done that we pass in, and the task ID for the to be the task ID that we pass in. Thankfully, since we're using SQLAlchemy, and we specified that this task ID field is a foreign key that references the tasks table, and the ID field within the tasks table, this when we create a new subtask and we specify the task ID, it automatically makes this connection for us. So now we can create some subtask. Let's just confirm that we have our task. And let's make a new request. Let's just duplicate this one. Let's call it create new subtask. And we'll pass in the task ID that we want to make the subtask for. So currently the only task I have is task with ID 1. So we'll pass in the ID 1 right here. And then let's pass in the body. So what are some subtasks for getting good at Smash? I don't know. Stop losing against Gonzalo. Maybe that's a subtask that we have to do. So the endpoint is slightly different now, right? So we have tasks, the task ID, and then slash another subtasks. So we have task, we have the ID, now we need subtasks. So let's push that. And now, voila, we can see that our ID was passed in, our description was passed in, our darn was passed in, and our task ID was passed in. So now if we go to get all tasks, this task has a new subtask associated to it. However, we can't see that subtask, right? It doesn't tell us what subtask is associated to it. So let's create a new field within task called subtasks, and it'll just contain all the subtasks that are associated to it. So we'll make a db.relationship. We'll make a relationship with another table. Now, the thing that's super jank about SQLAlchemy is that even though we've been referencing the table names in all of our little SQLAlchemy queries, right? So tasks is our table name. Here specifically in db.relationship, we have to pass in the class name. So this is the class name, subtask. So for whatever reason, this has to be in with capital S and not plural. I would say sorry, but this is SQLAlchemy, so they can apologize to you. Okay. So a few students asked on that and asked during office hours, hey, if for PA3, right, we have transaction and we have users. So if a user is deleted, what should happen to the transactions that they were involved in? Shouldn't they get deleted? You didn't have to worry about this for PA3, but we'll actually worry about this now. So if a task is deleted and there's subtasks related to that task, we want to get rid of those subtasks, right? And the way we do this in SQLAlchemy isn't by manually going through all the subtasks and deleting them if they're associated to a task, but rather by just specifying cascades equals delete. So this allows us to delete all subtasks associated to a task whenever we delete the parent task. Cool. So let's go to get all tasks. And when we serialize it, we want to return the subtasks that we want to return the subtasks associated to it as well. Tasks equals s.serialize for s in self.subtasks. Also, I don't know what just happened to my terminal, but cascade. Oh, it's a cascade. Sorry. Cool. So we just created a subtask field, right? We return it when we serialize it. Make sense so far? So let's go to a Postman. This is our serialized output. Now, if you look here, right, we created that relationship between task and subtask, and now when we get all tasks, you can see the subtasks that are associated to it. Awesome. Okay. Now, one thing we can observe is if we delete a task by its ID, right? We just deleted this task, and we create a new task, and it has the same ID. You can see that the subtasks is now cleared. So the cascade equals delete thing worked, right? It like deleted all the subtasks associated to the task. So that's one thing to note. Let's just add this for the sake of demonstration, right? So we have our tasks and we have our subtasks. Cool. So we just covered one-to-many, and next we want to be covering many-to-many. So let's do that. Let's say our tasks can have a category that it's associated to. As a many-to-many relationship with category. Let's say we're making an app and you can like tag a task by a category, for example, homework, or like, fun, activities, or whatever. Right, so let's create a subcategory model. Right, we're making a new class called category. db.model. This is the category model. So the table name is our ID. So this should, again, look very familiar to, we'll use our favorite trick when programming, once again, called copy and pasting. We'll have like a color that's associated to a category. Let's do that. So let's say homework is like red because it makes us mad. And then, I don't know, something fun is like blue or something. So we can add a color to it. It'll be a string. And it will not be nullable. Cool. Now let's define the initializing function, self and kwargs. Initializes a category object. Self.description equals kwargs. Nothing. Self.color equals kwargs.color or nothing. Let's serialize it. So serializes a category object. And we'll return the dictionary with ID being ID field, description being the description field, the color being field. Okay, so we just created a new category object that has ID, description, and color. But right now, we don't have a relationship between categories and tasks. So we want to be able to label a task, assign it a category. So the way we create this many-to-many relationship is by having another field here called tasks, and having a field up here in our tasks called categories. Right, and let's do it this one by one. So let's go to tasks first. Right, tasks. What is task? Well, it's another db.relationship. We have to specify the class name that it has a relationship with, which is task. And then it has to have a foreign key. However, this is a many-to-many relationship. And again, as we discussed from lecture 3, the way we model a many-to-many relationship is by using this thing called an association table or a join table. So we'll be creating this association table in a second, but let's just call it association table that we'll create in a second. And we'll do this thing called back populates equals categories. So what exactly is this doing? Back populates, if you make a relationship in one direction, makes that same relationship in the other direction. So what I mean by that is if, let's say, I associate a task to a category, that category will be associated to that task as well. Hopefully that makes sense. So if you do like parents.child equals a child object, then child.parent will also return that parent object. That's what backpopulate does. So let's copy this and go up to our task model, db.relationship, category class. The secondary will be an association table that we'll make in a sec. I'm very struggling to pronounce that word. And it will backpopulate with our tasks field in the category table, right? Right here. Okay, cool. Finally, let's make this association table. Okay, association table equals db.table. We'll call it association db.column. So this is a very similar format as the model. A table and a model is very similar in SQLAlchemy. The difference is that a model is almost like a blueprint. So you make objects of that class, right? And the class is kind of like a blueprint in Python as well. The table is more like a lightweight version of a model. All you do is define a few columns in it, and it's very suited for association tables because all they store is a few IDs, like 2 columns of IDs. So we'll make this column, we'll call it task ID, and it is an integer. It is a foreign key, and then, like we did back down here, where is it? Right, foreign key is a table name dot the field name. So it is task.id as well. And we have another column called category ID, which is another integer, and it references categories tasks.id. Okay, cool. Okay, now, when we serialize our task object, right now we're only returning ID, description, done, and subtasks. So likewise, we want to be returning our categories. So let's add that to our field. Oops, I already did. Okay, let's add this to our serialization. Categories is c.serialize for c in self.categories. So we serialize each category object that's in our category, a list of categories. And we can do the same thing down here with tasks. So we have tasks in our category model. So we can do tasks equals t.serialize for t in self.tasks. Now, there's a glaring issue here, a cyclic kind of connection here between the two models. When I call task.serialize, it will serialize every category that's associated to it. When I serialize each category, it'll serialize a task that's associated to it. So it'll be an infinite recursion kind of thing, and we don't want that. So we can define another function. Maybe we'll call it simple serialize, and we won't have the task for this one specifically. This will be very, very important for PA4 because you are going to have a many-to-many relationship. And if you try to serialize, like categories and tasks in here and categories in there, you're going to end up with, well, an infinitely nested dictionary. So yeah, make sure you, understand what I'm doing here. So simple serialize is a category object. Okay. Now we will implement our last endpoint, being to assign a category to a task. Okay, let's do that. So we'll get a task as usual. Task.query.filter by ID equals task ID dot first. We'll check if the task is none, and we'll return a failure response. Task not found. Body equals JSON dot data, right? Body if task is found. So that's like a little note in our code. Description equals JSON body.get description. Color equals body.get color. And now that we've extracted the information we need from our request body, we can create new category object. Right, so we'll create a new category if it doesn't exist. If it does exist, we'll just use the existing category. So if it doesn't exist, otherwise assign task to existing category. So we'll do category, a variable, category dot query dot filter by. Oh, I forgot to import it. I'm going a bit too fast. Okay, so let's import the category that we just created. And we'll query by, let's say, the color. If the color matches, it's the same category. So we're matching the color field in the category table with the color that's passed into us. That's what color equals color is doing. If this is misleading, you can change this to like color 2 if you really want to, but I'll just keep it this way. We've got the first category that exists. If the category doesn't exist, then we'll assign a new category by creating one. Description equals description, color equals color. And if it does exist, then it wouldn't go into this if statement. It would just get the category that it found. So we can do task.categories.append, right? Task is a task object, and the task object has a categories field. Okay. So we're appending the newly created or already found category to our categories field. And finally, since we made a change again, we'll commit that change. And we will return a successful response containing the task that we just assigned the category to. Okay. So we're running slightly low on time, so we'll go ahead and test this. And then we'll start the attendance Kahoot. But hopefully this logic makes sense so far. We're creating a new task, or if we didn't find the task, then we'll complain. Otherwise, we'll try to create a new category if it doesn't exist. If it does exist, we'll just use the existing one and assign it to the task that we found. And then we'll commit that change. Cool. So let's create a new endpoint. Assign category to task ID. Right, very descriptive name is important. And our endpoint is this, task/task ID/category. So it's task/task ID, which we only have one right now, and then category. And the two fields we want to be passing in are the description and the color. So red, because I'm angry. And description is like, it all sucks. Okay, let's push that. And we got an internal server error. Wait, what is the? Oh, my postman crashed. No, it didn't. Soft.id. I didn't what? Oh, oops. Did I like here? Oh, simple serialize. Yeah, this is supposed to be simple serialize. Thank you for the catch. So if I don't do this, it'll infinitely recurse like I mentioned earlier. So let's simple serialize it so it doesn't actually give us the task, and then which give us the category and which give us the task and so on. Where is it? Right here. Now if we hit this endpoint, wait, no, that's the wrong endpoint. This endpoint. Cool. So we have our ID, we have our description, get good at Smash. We're still not done with it, and our subtask is this. I accidentally just created a second one. And our category is that. So we successfully created a many-to-many relationship with our association table. And if you really want to look into what's inside the association table, you can go ahead and do that from, you should be able to do that from the content you learned last time and this time around. Okay, great. So we're just 5 minutes before time. So we'll take last minute questions and then get started with the Kahoot. So does anyone have any questions before we move on? Are you good? Does it make sense? Hopefully it makes sense. Okay, nice. All right, so let's do a Kahoot.